Okay, this is Dr. Williamson working in equilibrium problem. Here we have this problem. Nitrogen dioxide decomposes according to this reaction where the equilibrium constant based on pressure is 4.48 times 10 to the minus 13 power at a certain temperature. If 0.75 atmospheres of NO2 is added to a container, come to equilibrium, what are the partial pressures of NO and O2? All right. So what we need to do is I'm going to go 2 NO2. We're going to assume this is all in the gas phase. So I'm not going to constantly write the G for gas. 2NO plus O2. Going to make our ice chart. Okay. CE. Draw. This is going to be 0.75 atmospheres. That's a 7. And it says it was added to a container. It implies that it was only that, none of these. That means this is going to go down by 2x because of that 2 coefficient. This will go up by 2x. This will go up by x. So at equilibrium, this will be 0.75. Okay, make that a little more clear. 0.75 minus 2x. It's a minus sign. This is a decimal point. This will be 2x. This will be x. Let me clean that up. 0.75 minus 2x. At equilibrium, Kp will be equal to the pressure of NO squared times the pressure of O2 divided by the pressure of NO2 squared. That'll be equal to 2x squared times x all over 0.75 minus 2x quantity squared. And that's going to be equal to 4.48 times 10 the negative 13 power. This is going to be a quadratic equation or a cubic equation. Hard to solve. So we want to see if the x is small approximation works. The x is small approximation is valid when this divided by the value of k is much greater than 400. So we're going to go 0.75 divided by 4.48 times 10 to the minus 13 power. Okay. I'm not even going to calculate that on my calculator because this is really, really small. This is going to be much larger. This ratio will be much larger than 400. Okay. I don't even have to do it on my calculator to know that. So the x is small approximation is going to be valid. So what I'm going to end up with when I do the algebra for this, and I realize that 0.75 minus 2x will be approximately equal to 0.75 because x is small approximation. I will end up with 2x quantity squared will be 4x squared times another x. That'll end up being 4x cubed over 0.75 quantity squared is equal to 4.48 times 10 to the minus 13. Solving for x, x will be equal to 0.75 quantity squared times 4.48 times 10 to the minus 13 divided by 4, and it will be the cube root of this. And if I did it right on my calculator, and I might not have, so check it, and if I did it wrong, put a note in the comments. I got 0.0000040, the two significant figures. So then the pressure of O2, partial pressure of O2 at equilibrium, will be equal to x, and that will be equal to 0.0000040 atmospheres, ATM. The pressure of NO will be equal to 2x, and that will be double this number, so it'll be 0.0000080 atmospheres. Okay, so you had to use the x small approximation. You have to make sure that when you square this, you square the 2, because it's 2x quantity squared. 2 squared is 4. You get 4x squared. You have another x. That's where this 4x cubed comes from. 0.075 minus 2x quantity squared becomes 0.75 squared, because the x is small approximation reduces 0.75 minus 2x to become 0.75, right? And don't forget, you got to square that. Okay, hope that helps. Remember, you got to go through the algebra step by step carefully on your own. And if I did this part wrong because I punched in my calculator incorrectly, I think I did it right, but let me know in the comments. Right, hope that helps.